All right, so to start out chapter 7, we are going to look at solving systems of equations. So when I solve a system of equations, I am trying to figure out where two graphs intersect. So if we were to graph these two things, I would want to know what point or what points do they intersect. Now these two equations, these are both lines, so this is called a system of linear equations. And so our first couple of examples are going to involve those, and then we're going to talk about nonlinear equations like parabolas and circles and how do we find the solutions to those. So there's two ways when you have a linear equation to solve. I'm sure at some prior algebra class you've seen this before. What we're going to do first is we're going to talk about the way to do it, which is called substitution. And what substitution means is I am going to take one of the equations, solve it for a variable, and I'm going to substitute it in the other. Now here's the key to substitution, and here's the only time I would substitute using a linear equation. Is there a variable that is super simple to solve for? Meaning one step, meaning no division, because we want to avoid fractions. So on this problem, there's really two choices. Either the x or the y would be pretty simple to solve for, but I'm going to say the solving for the y is even simpler because I can add over and I won't have anything to divide by. I would not choose the x or the y in this equation because you're going to end up with fractions, and our whole point is to do this as quickly and as easily as we possibly can. So what I'm going to do is I'm going to add the x over on this equation and get y is equal to x plus 3, or 3 plus x if you prefer that order. And now what I'm going to do is this says that wherever I see a y in the other equation, I'm going to substitute x plus 3. So in this top equation that starts off, I have 3x plus 2 times y, so 2 times, but now instead of y here, I'm going to put y is equal to x plus 3, and then that equals 11. And that's the substitution step. That is potentially new for you, or I'm guessing you've seen it before. The rest of this is a linear equation to solve. So I'm going to solve it by getting the x's on one side, the numbers on the other, and then dividing. So I have 3x plus 2x plus 6. Don't forget to distribute. That's the most common mistake made on these problems. Equals 11. 3x and 2x is 5x. I'm going to subtract the 6 from both sides, and then divide the 5, and I get 1. Now, that's only half the answer. Remember, if we're trying to find where graphs intersect, that is going to be a point, so I'm going to get an ordered pair. So now I'm going to take this x value, and you can plug the x value back in the top equation if you want. The bottom equation, I'm going to plug the x value into this equation that I've already manipulated a little bit. And this equation says whatever the y value is, or excuse me, the y value is going to be whatever the x value is, which is 1 plus 3. So the y value is 4. Now, notation is important to me when I am looking at your work. To let everybody know this is a point, we are going to write it as an ordered pair. And so the x value is 1, the y value is 4. And to distinguish this ordered pair from an interval, what I'm going to do is I'm going to write it as a solution set. And so I'm going to put some squigglies around. So where do these two lines intersect? They intersect at the point 1, 4. My assistant's sleeping.